You're watching PowerNation. Some of you may disagree, but we think that the Ford Granada shows plenty of promise as a project vehicle.
Except for its engine. It's anemic.
Today on Engine Power, we fix that. Today on Engine Power, we're going to do something that we have not done in a while.
A car!
Now, if you remember right, we helped an owner get this car running because they wanted to sell it. Well, it turns out we decided we couldn't live without it. So after a little bit of paper changed hands, we are now the proud owners of this 1977 Ford Granada Ghia. Now, it didn't run that great, and it took a little bit of work to get it into this spot. Here's how that looked.
Even though it had been sitting in a yard for a while, sporting a very flat tire and the usual signs of old age, it was clear that the owner of this Granada took good care of it. The paint was in excellent shape, and the frame and body were almost rust-free. At first, the engine didn't run at all. After troubleshooting a couple of issues, we found the problem: a distributor that was missing its rotor. After replacing the rotor, cap, plugs, wires, and air filter, the engine ran pretty well, and the smoke started to clear up.
Back in the shop, we discovered a worn-out gasket was the source of the transmission leak. After changing the filter and gasket, we gave the Granada fresh transmission fluid along with an oil change. Finally, we upgraded the old reverse lights to LEDs. After a few minutes cruising around in this old Ford, we couldn't stand the idea of parting with it.
This car is exceptionally clean and relatively low miles, but you're probably wondering, why a Granada? Well, it's not the raciest of cars, and it might not be your piece of pie, but for us, that's perfect because this is going to be a sleeper of sorts. That means giving the engine a bunch more power, doing the drivetrain and suspension upgrades that go with it, but not really touching the look of the car. But before we do all of that, we need a baseline dyno run, so we're going to get it on the chassis dyno and make a few pulls. Speaking of that, maybe we should name this pumpkin pie.
I love pie.
Sounds good. Are you dynoing?
That's weird. Yes.
See what this thing does.
I think it's more exciting sometimes to do the baseline, because after you build something, you kind of know what it's going to do.
I just like to see the change. Like, this thing's probably not going to make a lot of power, so it'll be fun to see the before and after, you know?
Right. There we go. It didn't like a wide open throttle.
No, it was a little rough. Definitely starting to miss there. Not bad though. 101 and 185
triple
pounds.
Digits. It made triple digits on the first
I mean,
hit.
that's not bad. These things made like 120 or 130
yeah.
stock, so you know that's what they claim. So that's pretty good.
I'm pumped. It made 100 horse. Let's do one more. It kind of cleaned up.
99.
Oh, okay.
Yeah, it's about the same.
It was a little.
Kind of has that natural rev limiter.
Yeah, whatever that was. I think it's a combination of two barrel, and it doesn't like anything that we're doing.
Yeah, I mean, it's old and tired, so we could mess with it and see if we can get it to go a little bit better. But
the only thing you would really do is jack the timing up or something like that. With this,
we can do something really easy and pull the air cleaner off.
Let's see if we can remove some restriction. I'll wait till you do that modification. These are the easy mods I like. Ah, yeah. Oh, we might have got a little more RPM out of it.
Yeah, it's about the same. 99, basically 100.
All right, well.
That's about the same. Whenever you pull the engine from an older vehicle, it's always good to have a plan B. Up next, plan B.
The baseline dyno runs confirmed what we already knew. This Granada has plenty of potential, but it needs some major power plant upgrades. After removing the drive shaft, we'll cut out the exhaust system and drop the transmission. I was going to recommend don't pull that.
Oh, you should have said that.
But
too late now.
Too late now. One thing we really like about older cars, there's usually plenty of room to work in the engine bay. Even though we took our time and carefully removed the engine, it only took a couple of hours. There's not a lot of electronics on this 302, just a bunch of vacuum lines.
Good on the front, just make sure we're not catching anything in the back and we're good.
No, back's well, we're looking good.
A clean engine has several benefits. It keeps dirt and crud from getting into the block during teardown and reassembly. It also makes it easier to spot any leaks. Plus, it's just more enjoyable to work on. We are reusing some of the front accessories and bracketry, so we'll put them off to one side.
Oh, look at that. No broken ones. Nice.
Oh. Heck yeah, look at that. The teardown revealed an engine in really good condition.
Oh yeah, I got him.
But when we removed the cylinder heads, we found a set of 60 over pistons in the bores. Uh-oh.
Ooh. Anticipating this was going to be a standard bore, we ordered 30 over parts for the piston, right?
Yeah, I mean, that's just what happens when you order parts before you tear something down.
Right.
It's kind of a gamble we took, and normally we would wait, to see, but from a time standpoint, we kind of needed to get them, so that's just a gamble that we took, and so.
I have a solution.
Yeah, I know what your solution is.
I have a block that's been used in a previous project.
Yep.
It's already 30 over. It's going to have to be touched on the hone.
And we can freshen it up. And
we can freshen up, but we're going to have to use that because obviously it would take more time to switch out the pistons to get a 60 over pistons. We'll take advantage of our in-house Sun SV15 and torque plate hone the donor block for proper piston skirt clearance and cylinder finish. Even though this block has been run before, we wanted to change up some tolerances for our application, opening up the bores by 1.5 thousandths. We'll check our results often as we go. The auto dwell feature makes achieving proper bore geometry much easier. While Frankie cleans the crankshaft with lacquer thinner, I'll apply a thin layer of Total Seal assembly lube to the freshly cleaned cylinder walls.
After checking vertical oil clearance for all of the main bearings, they drop into place, followed by assembly lube and the crankshaft itself.
Smooth.
Next comes the main girdle and ARP main bolts. This block was previously align honed with the girdle in place, so we'll reinstall it. The main bolts are torqued to 70 pound-feet. Our rotating assembly came with a Molle Power Pack piston ring kit that includes 1mm, 1mm, 2mm rings. Top ring gap is set at 26 thousandths and the second ring gap is 28. This is the correct gap for our current application and anything else we might spray it with. We'll assemble the 4032 alloy forged Molle pistons and our Eagle 5400 long forged H-beam rods. They come with 7/16 ARP 8740 connecting rod bolts. With the rings completely cleaned, they can be installed on the pistons. The first and second ring gaps are placed 180 degrees apart in line with the wrist pin. The oil control ring gaps are also 180 degrees apart, but offset from the wrist pin. Before they drop in, the rods and pistons receive a coat of assembly lube.
Up next, the small block gets sporty aluminum cylinder heads and a valve train designed for high RPM fun. Because this is a special build, we're installing a custom ground billet solid roller camshaft from Comp. We picked out the lobes from their high torque series with the intake's duration of 248 degrees at 50 thousandths lift and the exhaust duration of 260 degrees. The lobe lift for each is 406 thousandths and they are set on a 110 degree lobe separation angle. We also converted the firing order to that of a late model 5.0 and 351 Windsor. We'll use orange thread locker to keep the Comp bronze retainer plate in place. The cam is rotated by a Comp billet double roller timing set with a 9 keyway adjustable crank sprocket. Next, we degreed the cam. We set it at 105.5 degrees of intake centerline, which is 4.5 degrees advanced to give us great street manners.
Then we'll check piston to valve clearance with the head gasket, cylinder head, and valve train mocked up. The exhaust has 155 thousandths and the intake has 171 thousandths. Plenty. After applying a thin layer of silicone to the front of the engine, we'll gently press the timing cover gasket into place. We left the outside of the timing cover looking a little crummy to keep this engine from drawing attention, but the inside is perfectly clean. After we press on the balancer, we can tighten down the bolts. We're using a chromoly ARP Oil Pump Driveshaft along with a Melling high-volume oil pump that's been clearanced for the front main bolt. The Canton oil pump pickup is a specific match for our Canton front sump road race pan that we found at Summit Racing Equipment. The pan is held down by a black oxide 6-point ARP bolt kit. To go with our custom cam, we got a set of Comp Sportsman solid roller lifters with bushed rollers, which will handle our extreme street application. Like we said, and you've probably noticed, we're trying to make this engine as inconspicuous as possible. We're not trying to make it look stock, but we are going to use as much of the stock componentry as we can in order to disguise how much power it's actually going to make. We're not going to compromise when it comes to performance though, especially on the fasteners, and that's why we're going to be using ARP head bolts on this build. This head bolt kit was specifically recommended by the head manufacturer, and there's a really important reason for that. These heads are made to fit both 289 and 302 Windsors, which have a 7/16 head bolt, and 351 Windsors, which have a 1/2-inch head bolt. This kit comes with insert washers that locate the 7/16 bolts inside the 1/2-inch cylinder head holes. ARP does a great job of working directly with manufacturers to create a bunch of different kits for specific applications, so it's important to read the instructions and make sure you're getting the right ones. The instructions that came with our kit clearly say to put ARP Ultra Torque underneath the head of the bolt, leave the bottom of the washer dry, and since our head bolt holes go directly into the water jacket, we have thread sealer on the threads. We'll get our AFR 205 cylinder heads on, and then we can bolt them down.
The AFR Renegade 205s have a 2080 stainless intake valve and a 1600 stainless exhaust, housed in a fully CNC'd 58cc chamber. The 205 refers to the intake port CCs, and we have a 1550 OD heavy-duty valve spring set up for our solid roller. With a 4060 by 27 thousandths thick Cometic head gasket, we have a measured compression ratio of 10.84 to 1. The heads are torqued in multiple steps to a value of 70 pound-feet.
Our valve train is full of high-quality components, like this Jessel Sportsman 1.6 ratio shaft rocker system. This, along with the Comp 6/850 long, 3/8 diameter push rods, will keep the valve train under control at high RPM. The advantage of a shaft rocker system is increased rigidity, accurate geometry, and the ability to withstand heavy abuse under any application. These are higher-end, racy components, but they're easy to find at Summit Racing Equipment. They are installed in the firing order, and then lash is set cold at 18 thousandths across the board.
AFR recommends these Felpro gaskets to match their intake port. We'll put down a bead of silicone on the china walls and around the coolant ports. Then the Edelbrock Victor Jr. intake manifold is carefully set into position and torqued to 22 pound-feet.
Our engine is almost completely together, and there's only a few parts we need before we can give it a paint job to help disguise some of the new pretty parts that we've been putting on. And that means we're going to need a new water pump and an alternator, because those are things you don't want to have to replace once everything is already together and in the car. So for that, we turn to the Duralast brand, because we're looking for something that's going to have great longevity and work just as good or better than the OE stock components. They offer a cast iron version, which is a direct replacement for the original, but they also offer a heavy-duty aluminum version that has the exact same dimensions, but is about 7 pounds lighter, and saving weight in a car is always good. Both of these parts are made with completely new components. They are not remanufactured, they are brand new. We're also going to be installing a new alternator, so we're going to use a Duralast Gold. These are made also with completely new components, and they are triple tested throughout the manufacturing process to make sure that they work just as good or better than their OE counterparts. These components are going to work great, and they're going to last a long time in our sleeper street car. After laying down silicone, the water pump gasket is pressed on, and then we'll apply a little more silicone. Finally, the water pump is bolted down. All these shiny new pieces would definitely go against the sleeper concept of this build, so we gave the engine a patina finish using Ford blue and matte black paint and a little dirt to age everything. Stealthy. Up next, it may not look like much now, but the small block has got the goods where it counts, in the dyno cell. We've shown testing on carburetor sizing before, and today we want to take a minute to talk about the different styles of carburetors, how they're rated, and what factors can actually affect carburetor sizing. We'll start with the basics. Carburetors are described normally by the flange they bolt to and how many barrels or venturis they have. Generally, we see 1-barrel, 2-barrel, or 4-barrel carburetors, and in performance applications, we're usually using a 4150 or square bore flange or a 4500 Dominator flange. The industry standard for carburetor sizing is by flow in cubic feet per minute. This is tested on specially calibrated flow benches, but the difference comes in how the carburetors are tested. 1- and 2-barrel carburetors are tested at 3 inches of vacuum, while 4-barrel carburetors are tested at 1.5 inches of vacuum. This seems confusing, but 1- and 2-barrel carburetors are generally going to see more manifold vacuum below the throttle blades, so it gives a better indication of how the carburetor will react during normal operation. There's a simple formula to determine how much airflow an engine will need that you can easily do to give you a rough idea of the carburetor size you will need. You take the engine's displacement in cubic inches, multiply it by the max RPM the engine will see, and divide it by 3,456. This is a good starting point, but we have shown and generally see that a larger carburetor will make more horsepower. The big misnomer here is that a carburetor that is too big will flood the engine with fuel, and that's simply not the case. The carburetor itself limits how much air can enter the engine, but the fuel metering system, meaning the main jets, power valves, and air bleeds, along with how much air actually enters the engine, is what determines fuel flow. That means if the tune-up is right, drivability and power will not be adversely affected. There are other factors that go into carburetor sizing, and just like everything else in engine building, it's application specific. Things like what type of manifold, whether it's a dual plane or a single plane, and what kind of operation the engine is going to see, whether it's going to see low or high RPM acceleration rates, are big factors. If you need help figuring out what size carburetor you need for your engine, you can use Summit Racing's online CFM calculator or talk to the experts at Summit Racing. They'll get you sorted out. For our engine, we're using the QFT Black Diamond 950 4-barrel carb with a 4150 flange.
For the sake of time, we've got everything bolted to the engine that was in the car. We have the entire accessory drive on, but we are not going to run the AC belt because, well, we're not running AC in the dyno room. But we have everything broke in and tuned up. So what we're going to do now is we're going to make a few runs to make sure the engine is fine. Now keep in mind, this is a street engine on pump gas.
Yeah, so because it's a street engine, I figure we do our first pull from 3,500 to 6, nice streetable range. We've got 35 degrees of timing, that's what we found that the engine wanted, and an air fuel in the mid-13s with our 950.
Oh, wait, don't blow it up. What a nice little engine.
All right, not bad. 442.5 pound-feet and 490.3 horsepower, right at 6,000.
All right.
That's about what we expected.
If you were stopping right here, it would be a really great street engine, but looks can be deceiving. We built this one to look docile, but not be as docile as it looks, if that makes any sense. So what we're gonna do now is we are gonna step up the RPM range. Now we are going to put it up there because we have enough induction, we have enough camshaft. Keep in mind, solid roller, good set of heads, good manifold, 950 CFM QFT black diamond. So,
and our valve train is set up specifically for this. So
it is.
We're gonna move out of the street range and go into 5,000 to 7,500 at the same rate.
7,500?
Yeah.
Oh. Well, that sounds like a real engine right there.
531.2 horsepower and 443.5 pound-feet.
That's nice.
Yeah, and peak power happened, let's see, right at 7,100. Our plan of maybe quieting this down might not work as well as we think, but I think, you know, we get that a lot, that people, they think that single planes can't, you know, they're not street manifolds, or, you know, you can't put a big carburetor on a street engine, but I think this thing's gonna run just fine.
It's gonna run just fine the way it is, and it's gonna be a lot of fun in the old frame rails of the spicy Granada there, so.
Heck yeah, well,
nice
good
job.
day.
Happy times. If you wanna see more cool builds and more cool content, go check out our website.